We're going to be looking at some fairly tricky A-level questions here and considering some tips and techniques that should give you some more success when attacking these sort of problems. All of the problems come from the first year of the A-level course, so the year 12 stuff, but we're still not going to be focusing on the content. We're going to be looking at these tips and techniques for problem solving. So for example, if you've forgotten how to do equations of circles, it's going to be up to you to go and revise that first and then come back and consider these tricky questions. Okay, here's the first one that we're going to be doing. Have a read of this before I talk about it. All right, hopefully you've already had a few ideas. Let's get stuck in. For all of the questions in this video, I'm going to be asking you these 5 questions. What chapter is it? What can I draw? What do I need? What do I have? And what algebra can I write down? These questions, if you ask yourself them, will help you to organise your ideas and make it easier to get stuck into a problem, start a problem. They're best explained in the context of the question that we were just looking at. So let's move to these to the side and make a start on the question. Here we go. All right, what chapter is it? Asking yourself this will help you to figure out what bits of your own understanding we might need to put into play here. This question is obviously a coordinate geometry equations of circles questions, and some things might be coming to mind with that to do with equations of circles already. What can I draw? Kindly, this exam question has already given us a sketch of the setup. So I'm just going to sketch that out quickly. Oh, lovely circle with centre C, 7, 0 and 1, 0. So an exam's already given you a sketch. This question of what can I draw sort of becomes what can I add to the drawing that's already given to me. I'm immediately drawn here to connecting these up to the centre. That's often useful in circles questions to draw on the radii, because now we know those are the same length, and we know from the equation of the circle that equals 10 means that both of these are root 10. All right. What do I need? Find the area of the part of the circle below the x-axis. So I need this here. Already drawing those bits on might give you a better sense of what we're going to be needing to do. So if you think you know what to do, pause the video now and give it a go yourself before I do it for you. Okay, let's finish this off. I'm going to answer these 2 other questions. What do I have? I'm going to look in the question for bits of information that I haven't used yet. Well, just from the sketch, I haven't really labelled on that this length here is 6. That might be useful. Let's have another scan. There's a 4 in there. There's a 4 and a 1 in there that I haven't used yet. In the equation for the circle, I haven't used the fact that I know what the centre of the circle is. It's 4, 1. Great. I think I've labelled on everything that I have. What algebra can I write down? Linked to what chapter is it? It's to do with circles. I know how to find out the area of a sector. That's going to be the fraction of the circle times the area of the circle. Great. I think we're in a really good position now to answer the question. Let's finish it off. Okay, well I know what r squared is. That's 10. 10's going to cancel out with this. This should just simplify it down to pi theta over 36. There. All right. We're going to need theta. How do we find theta? A bit of trigonometry. So I could use some sort of sine rule or cosine rule on this triangle here. But I'm a mathematician, I'm lazy, I'm looking for a quicker way. I'm going to use a bit of SOHCAHTOA instead. I'm going to use this right angled triangle here. this right angle triangle here, if that is a half theta in the top, this is 3 and this is 1, we have tan of a half theta is opposite over adjacent. I can get theta very easily. Jump into my calculator, making sure I'm in degrees, inverse tan of 3, that gives us what a half theta is, so times that by 2 and we get theta. Now because I've rounded that, I'm going to store this in my calculator. I'm going to store it as A. See, I did that. I pressed store and then just pressed the button with the A above it. So that's in A, just in case I'll need it again. All right, and I'll need it straight away again. The area of a sector, I'm going to times it by pi and divide it by 36. Area of the sector is this times pi divided by 36. Oh, I didn't actually need to store it because I'm using it straight away. Divided by 36 is 12.5. Okay. Now what else do I need? Well, the area of the segment is going to be the sector, take away the triangle. So that's going to be a half times the base times the height of the triangle. That's just 3. So our final answer, the area of the segment, which we shaded in red, is 9.5. Well done if you got all of that before I went through it. The next one I'd like you to have a real good go at before I go through it. Let's find it. This one here. Now this one hasn't got a sketch with it. So I think a sketch is going to be really important. Before I go through this one, have a really good go at it yourself. Try to persevere all the way to the end. Good luck. Okay, I'm going to do it now. Are you sure you've had a go? Only carry on if you've definitely had a really good go. We're going to do it. Let's push that. Oh, let's put it up there. Let's put it up there. All right. What chapter is it? Well, it looks an awful lot like equations of circles, coordinate geometry again. You might be noticing a theme here. What can I draw? A sketch is incredibly important this time. Centre 5/8, radius 6. This seems like it's mostly in the positive quadrant, so I'm going to focus on that. 5/8, it's just a sketch. It's just a sketch. Radius 6. Well, I do know that because of that radius 6, it's going to have to push that along a bit. It's going to intersect over here, but not down here. I think that might be important. Okay. That'll do us. Bit scrappy, but it's all we need. P and Q are both points in the circle. Coordinates 14, 8. Well, if this is 5, 8, then 14, 8 is going to be out here at the same height. Okay. I'm going to label on the radius, I think, so I don't forget that. That's got a radius of 6, which means that that point there is 11. And we've got tangents coming from the circle through that point there. Great. There's my setup. There's my setup. We've got P and Q. I don't think it matters which way around they are. And this is the point A. Nice. All right. What do I need? That's my next question. The area of the quadrilateral CPAQ. The area of this quadrilateral. Connecting points to the centre of the circle again. That's definitely going to be useful because I know that that is 6 and that is 6. Okay. This here looks like a kite to me. These two the same length and these two the same length. I reckon that's going to be really useful. What do I have? I've already labelled on an awful lot of what I have, but is there anything missing? What else do I have here? Often questions like this use bits of information from GCSE circle theorems. Another thing that I have are the right angles here and here. Let's just scan the question again for anything else. No, I think we've got everything that we have. Now what algebra can I write down? I don't think I need to write anything down now. I just want to get stuck in. I want to find the area. Well, the area of this kite, I think the easiest way to do that is going to be to split it up into 2. So in drawing that line, I immediately want to label on its length. Well, 14, take away 5, that's length 9 there. This red line has a length 9. All right, finding the area of this triangle. Well, it's a right angle triangle, so I'm going to use half times base times height, but I need base times height, where one of these is the base, one of these is the height. It's the perpendicular bits. So I'm going to need this length here. Let's call it B, sort of the base. I want B. Right, I guess this is what algebra can I write down. I have B squared at 6 squared equals 9 squared. Oh, we're really on a roll here. That gives us B squared at 36 equals 81. B squared is 51, 45. And so B is root 45. Ooh, there's a square number that goes into 45. 9. That is 3 root 5. Fab. So the area of just that triangle there is that there is half times 6 times this, which is 9 root 5, and so the area of CPAQ is just double that, so that's 18 root 5. Well done if you got that. If you got that but didn't get part B, pause the video again and have a go at part B. Otherwise, I'm going to give that a go myself. B. The coordinates of P and Q. Well, I'm thinking, once I've got P, I've sort of got Q as well because of the symmetry. I need those two lengths here. Right, my diagram's getting a bit messy. What can I draw? I'm going to draw another diagram. Just zooming in on the bit that I need. C, P. I'm just going to focus on those ones for now. Alright. How am I going to find this height here? At any point during this, if I give you a hint and you have an idea of yourself, pause the video and do it yourself. It's always better to try and do it yourself before I do it. Alright, and we have the area, oh, we had that was 3 root 5, and we had the area is, there, just the triangle was 9 root 5. Well, if I know the area is half times base times height, and it's like we've twisted the triangle around now, so the base is like 9 now, I reckon I could get that height. So half times base times height is 9 root 5. I'm thinking of the triangle from all the way up. Right, I can definitely do that. Divide by 9 times by 2. I get straight away h is 2 root 5. Fantastic. And now I reckon I can find this length across as well. H, let's call this x. We haven't used x yet. Just up to here. Let's use a bit of Pythagoras. X squared add h squared equals 6 squared. 4 times 5, that's 20. X squared add 20 equals, oh, this is going to be so nice, equals 36. X squared equals 16, so x is 4. That seems very nice. That's leading me to think there must have been a nicer way of getting that. Anyway, this means we can get p straight away. So p is going to be, I'm going to put it down here, p is going to be, well, crossways it's going to be 5 add 4, that's 9. And vertically it's going to be 8 add h, 2 root 5, great. And q is going to be similar, but downwards. Again, a very well done, very big well done. Have you got those yourself? Fantastic. I'm happy with that. Quite enjoyed that. That was very nice. Let's go on to the next one. Let's go on to the next one. This one. This one. This one's going to use some more skills now. Again, pause the video, have a real good go at it yourself, and really remember these questions to ask yourself. There we go. Pause the video, give it a go. Okay, my turn. I'm excited to get going with this because I enjoyed the last one. I'm so excited that I've already drawn the sketch. Okay, what chapter is it? Now you should have noticed that this isn't just the coordinate geometry chapter we were doing before. This includes some, I reckon it's going to include some integration because we're asking for the area below a parabola. So already my integration brain's working since I've asked myself that. What can I draw? What can I add to this diagram that's already given to me? Well, the circle's got radius 2, that's not on there yet. So this is going to be negative 2, 0, and this is going to be 2, 0. I might as well label on that the equation of that parabola. That is y equals 1 over root 3 4 minus x squared. Since I've labelled on that parabola, I think I want to label on the equation of the circle as well. This is sort of, what algebra can I write down? These, we don't have to do these in this order. What algebra can I write down? I want to write down the equation of this circle. Well, if the centre is at 0, 0, it's just going to be x squared odd y squared equals 4. That might not only just help me get into the problem, that might get me a mark in an exam as well. Alright. Now, is there anything else that I have that I haven't written in? No. What do I need? The coordinates of Q. Now I have an association in my brain of finding the intersection between two curves as simultaneous equations. I want to solve both of these at the same time, and that would get me actually both P and Q. I want to solve both of these at the same time. I'm just going to take that root 3 over there. I'm going to times both sides of that by root 3. That looks like it might be nicer. And x squared add y squared equals 4. As before, if you got stuck and haven't got up to this stage, pause the video now and give it a go from here. But I'm going to get stuck into this simultaneous equation. I reckon the easiest way of doing this is to rearrange this one to give x squared equals 4 minus root 3y and put that in there. The aim with solving simultaneous equations is to always eliminate one variable, and so this will get me an equation with just y in it. A quadratic equation here. So y squared, oh my god, the 4's cancel out, that's so nice. Y squared minus root 3y equals 0. So y equals 0 or root 3. It makes sense that y could be 0 because the curves meet here where y is 0. But this indicates to me that this height here is root 3. Okay, so that's got me my y value. I just need my x value. Which one do I want to plug it into? I want to plug it into the bottom one. Then x squared add root 3 squared equals 4. X squared plus 3 equals 4. X squared is 1. And x equals plus or minus 1. Remember your plus or minus. But we're only asked for Q. So we're only asked for the positive one. And we've got what we need. Fantastic. Okay, that was only the 3 mark bit. It seems like the next bit's going to be a bit juicier. Find the exact area of the shaded region. Okay. Ooh, a bit of magic there. So that I can still have a diagram. Let's get stuck into this bit. This is going to be quite tricky. Let's ask ourselves these questions again. What chapter is it? Well, it's area under parabola, so I think it's going to use some integration this time. What can I draw? Now I've got this diagram here, but I think we can draw some other things to help us find what we need. We need that top little crescent bit there. I think that is, I'm going to split this up into what I know how to find out. That's going to be the taller bit below the parabola, take away the bit below the circle. We're going to remember that that's parabola and that's circle. Okay, I'm splitting up what we need and trying to work backwards back to what we have, because this bit here, the area underneath the parabola, is an integral between minus 1 and 1 of 1 over root 3, 4 minus x squared. Great. I might as well work through that bit. Now, let's figure out what that integral is. That's going to be, well, that 1 over root 3, I'm going to just take out to the outside. That's nicer. Add 1 to the power divided by the new power. 4 becomes 4x. Add 1 to the power divided by the new power. third x cubed. That is, well, we plug 1 in and take away this one, plugging negative 1 in. Minus 4, negative, negative. There's so many negatives in this, got to be careful here. Okay. 4 lots of 1 over root 3 minus that plus that minus that. I should have left that 1 over root 3 on the outside. That was silly of me. We've got 4 minus a third, add 4 minus a third. That's 8. Take away 2/3. That's 24 thirds, mate. 22 thirds. There we go. Quick maths. That's 22 over 3 root 3. I'm going to times top and bottom of that by root 3, I think. I think I'm going to call that 22 root 3 over 9. Fab. Oh, that was a slog. Let's take stock. We've got the area of the tall bit there. We still need this other bit. The area underneath the circle. Let's do a bit of jiggery pokery again. I'm going to show you my magic this time. So I still have my sketch. There we go. Underneath the circle. Okay. It's like we're asking ourselves these questions multiple times through the thing. And if you train yourself to ask these questions, you'll get to this stage. We have, what do I need? What do I have? I need this. I need the area under the circle. What do I have? I've got so much on this. I've got 2 there. I've got root 3 there. And I want to find a way of getting this. I'm going to split it up into things that I know. I'm going to split this up. I know how to find the sector of a circle. So how to find the area of a sector of a circle. So I've split it up like that. Each of these triangles, that's easy to find. Half times base times height, that's half root 3, so both of them together is just root 3. Great. Sector of a circle. What do I have? I have the radius. What do I need? I need this angle in here. Okay, we could, here's a plan. Well, we've got right angle triangle here. I could use Sokotoa. I could find that angle, which then using some Z angles would give me theta. That's how I could get theta. I've noticed something though. That definitely would get it, but a bit of a shortcut. We have a triangle here that's 2, 2, 2. That's an equilateral triangle. I know straight away, in an equilateral triangle, the theta is 60 degrees. Don't worry if you didn't notice that. That's a bit of a shortcut. You could have used Sokotoa, but I quite enjoyed spotting that. Alright, now I definitely know how to find the area of that sector. So, seems like we're in red now. The area of that sector is the fraction of this full circle times pi r squared. That's a 1/6. Blah blah blah. That's 2/3 pi. Great. Oh, now let's put it all together. This is mad. We wanted that top bit there, and we have split that up into the bit below the parabola, minus the bit below the circle, which is those two bits. Okay, so that was the bit below the parabola, 22.309. Minus root 3 plus 2/3 pi. Oh, doesn't look as scary right now. Let's do 22/9 of something minus a whole thing. That's going to be 13/9 of the thing. Minus that, minus 2/3 pi. I'm going to give that a big bubble because I'm very proud of it. A huge well done if you got to that, but little well dones if you got to certain bits along the way. These questions here really helped me to get to it, and hopefully you've noticed how I'm sort of asking myself these questions along the way. Take a break now before doing the next one because that was quite heavy, but the next one I'm purposefully not going to go through. It's not actually quite as hard as the one that we just did, but I'm not going to give you the answers because I really want you to persevere to find the answer yourself. Once you've gotten an answer, think of ways that you could check that it's definitely correct. But importantly, do that yourself. And hopefully you'll feel some satisfaction having done so. I'm definitely feeling satisfaction having worked through that beast of a question there. Good luck with it. I hope you have fun.